Hai, Assalamualaikum warahmatullahi wabarakatuh. So, hari ini kita akan sambung lagi dalam tajuk yang sama, IIR system. Macam mana kita nak design filter yang ada dalam IIR yang dinamakan sebagai Butterworth filter. Biasanya dalam Butterworth filter ni kita akan design guna method yang pertama, iaitu bilinear transformation. Dalam bilinear transformation sebenarnya kita ada 4 step, which is Vicky akan terangkan lebih lanjut tentang macam mana kita nak design Butterworth filter guna bilinear transformation. Seperti yang saya kata tadi, kita ada 4 step. Yang pertamanya adalah determine characteristic. Kita kena cari omega C, omega cut off frequency, apa-apa karakteristik yang berkaitan dengan bilinear transformation. Kemudian kita perlu cari transfer equation, iaitu HS, yang kita akan refer pada table. Kemudian daripada HS kita akan transform pada HZ, dan kemudian akhir sekali kita akan obtain time domain. Itu adalah berkaitan ataupun mengikut apa yang soalan mahulah.
Tak dengar aku.
Okay, I will explain in detail the steps to design the filter. Okay, first step, in the question they will be given the filter characteristic, delta S, delta P, or omega S. This is one type of the question. The second type of question will be given omega C and N, and the last type of question will be given omega C, omega S, delta S, or omega C, omega P, delta P. So depending on the filter characteristic given, we will find omega C and N. N is number of filter, order of the filter. So by determining the omega C and N, we can use the table to get the transfer function HS. Okay, the third step is HS is in continuous time representation of the filter. We need to convert it into discrete time filter representation. Okay, after converting into HZ, the fourth steps is we must refer the question again, whether they want difference equation or impulse response. Depending on the question, we need to change it into time domain representation. Thank you.
Okay, we're gonna continue the video by doing some example. We're doing example 1 from the notes. From the question is given omega C equal to 0.5 pi and the N is equal to 2. From this information given, we know that we need to use second order filter. So we're gonna refer to the table and get the transfer function HS. So from the table we get HS equal to 1 over S squared plus 1.4142 S plus 1. And then what we're gonna do now is we're gonna replace the S with the formula C in bracket 1 minus Z inverse over 1 plus Z inverse. Okay, so from this formula we don't know the value of C. We can obtain the value of C from two equations. The first equation is C equal to 2 over TS. If we want to use this formula, we need to know what is TS, but since we don't know the value of TS, we're gonna use the second formula, omega C equal to C dot tan omega C over 2. So we're gonna rearrange this equation and become C equal to 1 over tan in bracket 0.5 pi over 2. So from this we're gonna get 1 over tan 0.25 pi. Okay, and calculate it using the calculator. We get C equal to 1. And then from this we substitute the C inside the formula here. So S become 1 minus Z over 1 plus z inverse 1. Okay, then going to substitute this as equation into the transfer function. It's become hs to 1 is z is 1 over 1 plus z is 1 in bracket square plus 1.4142. Oops, no space here. And then 1 plus z. I write the 1 below this one, and then going to expand this equation, and it will become 1 over 1 minus z this one squared plus 1.4142 bracket 1 minus z negative 1 times by 1 plus z inverse plus 1 plus z inverse squared. And then we're gonna solve this equation, rearrange it, and it become 1 plus z inverse squared divided by 3.4142 plus 0.5858 z inverse, and we're gonna simplify this. I mean that we're going to factorize it, and it will become 0.2929 in bracket, so 1 plus 2z 1 plus z is squared. Alright, then 1 plus 0.1864 z negative 2. Okay, so this is our HS. And then if the question asks us to obtain the time domain representation, so we need to change it into we need to get the yn. So HS is equal to y. So now it's become yz and yz xz. Okay, that's all. The next person will continue this. Thank you.
Okay, now we will continue from the previous one. We write the equation back, and then we will move xz to the right and this equation to the left, and we multiply each one by yz and xz, and then we are using inverse transform table. We transform yz to yn for all the equation, and then we just left the subject yn to the left and bring the other to the right side. Okay, that's all.
Okay, after obtaining the transfer function, now we can plot the magnitude dB plot. So for the first graph, we will show the H omega. Okay, here. Okay, and the intercept of this graph, it will intercept 0.5 omega c right here.
Okay. As for the H omega in dB, we will start the plotting of the graph from the -3 dB. Okay, it's right here. And then just like the graph above, at 0.5 omega C, it will intercept, go down. So as you can see, the graph is like a low pass filter graph right here. Okay, next we move on to the pulse and zero plot. So from the transfer function equation, we obtain the pulse and zeros. Okay, as for the pulse, the first pulse is 0.49 something, so it's located here, and the other one is negative 0.49 right here. Okay, as for the zeros, we obtain it at -1 right here. The other one is also -1, so the plot here we have 2 zeros here, so I just write there 2, so you can see that. So that's all. Thank you.